Hello guys, welcome on Tesla Adventures. In this video today we are going to start the modern physics. And in the modern physics, first of all, we'll be studying about the photons and then radiation pressure and then the photoelectric effect, and then will come the Rutherford model, Bohr's model, dual nature of radiations, and atomic collisions. So, this is the topic sequence of modern physics. So, let us first of all start with the photons. So, a photon, as you have already heard about the photons, that photons were originally discovered by Max Planck, and obviously, you know that the photons uh, are the packet of energy or quanta of energy, and Max Planck discovered the photons in 1900. This is very strange to know that Max Planck do not give the name photon to the photons, and this name was given by a scientist or a chemist, Gilbert Norton Lewis. Okay, and this name was given in 1926. Now, Albert Einstein completely described the nature of light as photons, and they invented, in fact, they explained the unexplained effect that was photoelectric effect, and they were rewarded with Nobel Prize for photoelectric effect. So most of the research work or explanation was done by Albert Einstein in the photons. Okay, now let us discuss some properties of photon. So first of all, any according to the corpuscular theory of light, when the radiation interacts with matter, then radiation behaves as if it is made up of particles, which is called as photon. So this is the corpuscular theory of light, that when the light interacts or the radiation interacts with the matter. Now interaction means that collision with the matter or absorption in them. And then that light behaves like particles, which uh, called as photons, and those are quantas of fixed energies. Now, photons move with the speed of light through any medium, and the energy of each photon depends on the frequency of the radiation of which this photon is a part, and it is independent of the intensity of the radiation. So, let us suppose that there is a light wave of frequency nu. So when we are considering that light wave as a particle, so we would be mentioning its photons, and the energy of that photon will be h nu, where nu is the frequency of that wave. And the energy of photons is completely independent of the intensity of light or radiation. So this is equal to h nu, and nu can be written as c by lambda. So this is hc by lambda, and exact value of hc is 12375 eV, and divided by lambda. This is E. Now this lambda should be in angstroms. Then this value of E can be calculated by this result. Now, when photons travels from one medium to another medium, then their frequency remains same, but their wavelength and the speed changes. Obviously, this is the nature of light, that when light travels from one medium to another medium, then the frequency of light remains same, because frequency is DNA of the light. Okay. Now if the intensity of the radiation is increased, then obviously, see, when we are increasing the intensity of any particular radiation, then actually we are not changing that radiation, and therefore we are not changing its frequency. In fact, we are increasing the number of photons that are incident or that are traveling per unit area per unit time in that radiation. So energy associated with any one photon remains constant, but all over energy, which is the total number of photons traveling through a unit area and in a unit time, increases. So this is the intensity of a radiation. Okay, so by intensity, by increasing or decreasing the intensity of a particular radiation, we are actually changing the number of photons and not changing the energy of each photon. When photon collides with any particle, then the total energy and the momentum of the system remains conserved, obviously, but number of photons may change because photons are sometimes absorbed or sometimes released in that collision. And photons are electrically neutral because they do not have any charge, so they do not interact with electromagnetic fields, and when the photons passes through electromagnetic fields, then they are not deflected by those fields. So photons are obviously the packets of energy, and their rest mass is zero, which means that you cannot you cannot find out any photon which is at rest, and therefore we can also say that there is no frame of reference in which photons are found at rest. But it is very strange to know that the dynamic mass of the photons is not zero. In the later part of the modern physics, which is nuclear physics, I would be discussing in detail about the dynamic mass. But at this point of time, I am just telling about this formula, that m is equal to m naught upon under root 1 minus v square by c square. This is the relativistic mass of a moving particle. And according to Albert Einstein, the mass of a moving particle increases. Okay, I am telling that I would be discussing this complete equation and this relativistic mass and dynamic mass in the nuclear physics in detail. Now for photons, we know that speed of light v is equal to c. So m naught is equal to m into under root 1 minus v square by c square. And due to the fact that v is equal to c, m naught is 0. So m is not 0 because m is the dynamic mass and m naught is the rest mass of photons. And the dynamic mass of the photon is the mass when photons are obviously traveling. So it can be calculated by this equation, is equal to mc square, and that energy is also equal to h nu for a single photon. So m of the photon will be h nu by c square, and nu can be written as c by lambda. So it can be written as h by lambda c. So this is the dynamic or kinetic mass of the photon. Now each photon has some definite momentum along with it, and that momentum p is equal to h by lambda, and whenever this photon is incident on any surface, then that photon transfers that momentum to that surface, and that momentum transferred per unit time is called as force. We would be discussing the radiation force in detail in the later part. Now number of photons which are moving in a beam per unit area per unit time are called as photon flux. The symbol of this photon flux is phi, and this is the number of photons moving in a beam per unit area per unit time. Now intensity of any radiation is obviously the energy traveling through that radiation per unit area per unit time, and we can say that intensity is equal to the energy of one photon and the total number of photons moving per unit area per unit time. So obviously intensity will be equal to h nu into photon flux, and nu can be written as c by lambda. So this is the intensity and photon flux relationship for a photon, for a beam of photons. Now when photons strike any surface, then they transfer their momentum on that surface either by getting absorbed or by getting reflected, okay, from that surface. And this momentum transferred per unit area per unit time on that surface is called as a radiation force, and in fact per unit time is called as radiation force, and per unit area per unit time is called as radiation pressure. So momentum transferred on any surface per unit time is radiation force, and that radiation force per unit area is called as radiation pressure. So in the next video we would be discussing the radiation pressure in detail. Thank you.